Hello everyone. This is Dr. Captain K. Sujata, Professor of Mathematics, St. Joseph's College for Women, Autonomous Visakhapatnam. In this session, I am going to discuss linear differential equations with non-constant coefficients. Under that, the Cauchy-Euler equation, part 1. Coming to the learning outcomes, after successful completion of this lesson, the student will be able to solve linear differential equations and also solve higher order linear differential equations, both homogeneous and non-homogeneous with constant coefficients, solve the differential equation by using Cauchy-Euler equation and understand the concept and apply the appropriate methods for solving differential equations. In the previous session, we have discussed following definitions and some problems on variation of parameters. Working rule to find the general solution of this is the equation by the method of variation of parameters in case the given equation is not in the standard form. These are the steps we have followed while doing the problems in variation of parameters. In case the given equation is not in the standard form, reduce it to the standard form. That is the first step. Now after that, find the solution of d square y by dx square plus p into dy by dx plus qy is equal to 0. Let its solution be y is equal to c1u plus c2v, right? Which is a complementary function of equation 1. This is the equation 1. Let the particular integral of equation 1 be yp can be written as au plus bv, where a and b are functions of x. After that, we have to find out uv dash minus vu dash. Why? Because we are going to use this value for finding the capital A and B values. Right? After that, next step is find out the A and B values by using the formulae. A is equal to this is a value, this is a formula, and B is equal to this is a formula. Right? Now, after that, after getting YC and YP, then form the general solution of 1 is y is equal to C1ux plus C2vx plus AU plus BV, that is YC plus YP. Right? Now coming to the this main content, that is about the Cauchy-Euler equation. Now what is about the Cauchy? What is meant by Cauchy-Euler equation is discussed. Now we are going to define a Cauchy-Euler equation in terms of the nth degree equation, an equation of the form. This is an equation of the form of degree n, where that is what is the equation you have given, x to the power of n d to the power of n y by dx to the power, that is nth order differential equation plus p1 into n minus 1th order n minus 1th derivative and so on, pny is equal to q, where p1 p2 and so on pn are real constants and q is a function of x. Defined on an interval I is called homogeneous linear equation or Cauchy-Euler equation of order n, right? Its operator form is, that is operator means that is a differential operator. We are going to introduce differential operator is nothing but capital D. Always we know that is a differential operator. D is nothing but d by dx. So here introduce, write down this is a differential equation in the form of capital D. So what this can be written as x to the power of n into d to the power of n plus p1 into x to the power of n minus 1 into d to the power of n minus 1 and so on, pn into overall we can take the y common, into y is equal to q of x. Cauchy-Euler equation can be transformed in a linear equation with constant coefficients by change of independent variable with the substitution. These are the substitutions in the Cauchy-Euler equation. So we are going to substitute these values. X is equal to u power z, or if we apply the log on both sides, we will get z is equal to log x for every x is greater than equal to 0, right? Greater than for every x is greater than 0, right? Equality is not there, just strictly greater than 0. Now after that, x into differential operator d is equal to theta, x square d square is equal to theta into theta minus 1, x cube dq is equal to theta into theta minus 1 into theta minus 2, and so on. So with that, x to the power of n into d to the power of n also we can write in the form of theta into theta minus 1 like this. Okay. Now coming to the problems. First one, solve 3x square into d square y by dx square plus x into dy by dx plus y is equal to x, right? Now first of all, write down this equation in the form of the differential operator d, capital D. So given equation in the what we call differential operator, we call it as an operator form, is 3x square into d square plus xd plus the overall we can take the y common into plus 1 into y is equal to x. Let it be this equation 1, which is a homogeneous linear equation. Now according to the previous slide, x is equal to, we can take x as e power z and z is equal to log x wherever x is greater than 0, right? Now d is equal to d by dx. Then xd is equal to theta. We can take xt as theta. In the already we are from the Cauchy. See from the previous one. See the previous slide once again. With the previous slide, see here, Cauchy Euler equation, what we have taken x is equal to, with that we have introduced the differential operator d. So xt value what we have taken theta, x square d square is theta into theta minus 1. So same thing we are going to use in the problems also. So here xt is equal to theta, x square d square is equal to theta into theta minus 1. That is nothing but theta square minus theta. Okay. Now using these two in the given equation 1 and 2. From 1 and 2 what we'll get? So substitute these two values in our equation, linear equation. What we'll get is 3 into x square d square, what we have taken here, theta square minus theta. So 3 into theta square minus 3 theta, 3 into theta minus 1. This value we substituted, plus x into d, plus x into d. What we have taken xd is nothing but theta plus 1 into y is equal to, what is the x value we have taken? X is equal to e power z. Okay. Now simplify this. From this what will get? 3 theta square minus 3 theta plus 1 into y is equal to e power z. Now again simplify. So 3 theta square minus 3 theta plus theta is minus 2 theta plus 1 into y is equal to e power z. Where now consider auxiliary equation from this. So f of theta is auxiliary equation. The f of theta can be written as 3 theta square minus 2 theta plus 1. Right. So auxiliary equation is f of m is equal to 0. This is auxiliary equation. In place of theta taken m. From that find out the factors of m. So we will get the factors like this: 1 plus or minus root 2a divided by 3. So clearly it is in the form of a complex number a plus ib. So whereas a is equal to here 1, then 1 by 3 and b is equal to root 2 by 3. So right. So otherwise we can take a as 1 by 3, a as 1 by 3 only, and b is equal to plus or minus that is root 2 through 2 by 3. This is in the form of a plus or minus root b. A plus or minus bi, complex number, right? Now from that write down the complementary that is a cf complementary function yc. What is the formula? What we have written in yc? What is the formula? E power az is equal to, I will show what is the formula of the, I will use the board, then I'll explain what is the formula for the complementary function as well as a particular integral. Okay. So use the board and pen also I'm using. All right. So what is the complementary from the auxiliary equation? Auxiliary equation can be written as in the form of f of m is equal to, we will get second degree equation in terms of the m square like this, right? So after that we'll get the values of m, factors of m can be always, sometimes we will get, suppose if we get the values of m in the form of the complex number a plus or minus ib, a plus or minus ab, then the complementary function yc can be written as e power az e power az, that is a is a real value and imaginary value, b is a imaginary value into a cos bx into a cos a cos ib a cos bz, a cos bz plus c1 into a cos bz plus c2 into a sin bz, right? So whereas here what is a here, the real value a is this one, and whereas b is the imaginary part, imaginary value in the complex number, right? So in the same way we can define about the particular integral. So how to do the go to slide? I will show in that where we are in the sixth slide, no? I will go to the directly. Okay. So these are the complex numbers. So from that YC we e power az. What is the a here? 1/3 plus into c1 into cos bz. What is the b here? Root 2/3 plus c2 into sin bz root 2/3z. Okay. Now coming to the particular integral. This is a formula for the particular integral. What is the formula? 1 by f of d into q. What is meant by q? So in the previous slide, this is a value of q. This is a value from the functional value. X is nothing but this is a q. So always particular integral in the particular integral, yeah, this is a formula for the yp 1 by f of d into e power z. So f of d from the previous slide, what is f of d here? 3d square minus 2d plus 1, right? So that 3 theta square here, f of d means f of theta. F of d is nothing but f of theta. F of theta can be written as 3 theta square minus 2 theta plus 1 into the q. Q is nothing but e power z here. So here, suppose if it is a e power z, substitute this a value, e power az, no? If we substitute this a value in this denominator part, if we get non-zero value in the denominator, then directly we can take this value as a yp. Otherwise, if we are not getting, if we get this value, denominator value, if we get 0, so we can observe in the next problem, if we get 0, so there are the formulas are there, we have to follow that formulas, right? So after getting yc and yp, then take the general solution is y is equal to yc plus yp. Now substitute yc and yp, then simplify that, we will get the general solution. This is about the first problem. Coming to the second problem, what is given here? Solve x square d square minus 3xd plus 5 into y is equal to x square sin log x, right? So given equation is in the operator form. So write down the given equation in the form of the operator form is x square d square. Already it is given equation in the operator form. No need to convert again. Let it be, this is the equation 1. Again, x is equal to e power z, z is equal to log x. Same for every problem. These two steps will be the same. Now from 1 and 2, what this can be written as theta into theta minus 1 minus 3 theta plus 5 into y is equal to q. This is a q. So what is given? E power 2z. X square is e power z kada. Now substitute here in this. These values in this is substitute. So we will get e power 2z into sin z. This is a q, right? Now from that, write down the auxiliary function. What is the auxiliary function? Auxiliary equation can be written as f of m is equal to 0. That is nothing but m square minus 4m plus 5 is equal to 0. Again, m value, the factors of m we got in the form of the complex number a plus or minus ib. So here a is 2, b is 1 because I coefficient is 1. Right, from that complementary function yc can be written as e power az. So because a is 2 into c1 into cos bz, b is 1 plus c2 into sin bz, b is 1. Right. Now coming to the particular integral, that is a yp can be written as, what is the formula? 1 by f of d into e power z. So f of d means f of theta. F of theta means theta square minus 4m plus 5. That is a minus 4 theta plus 5. This is a f of theta into e power z. What we got it in the from the previous slide, the e power 2z into sin z, right? No, suppose if we have like this is a combination of the two functions. This is a combination of the two functions. So this can be written as, so here suppose any function, any q function in the form of exponential function as into trigonometrical function. If it is given like that, first of all, separate exponential function, write down the exponential function outside. That is separately write down like this, e power 2z into this function. Now in the denominator, keep as it is like this. In the denominator, we have written this one. Now in this, in the exponential function, a value is 2. Now, take that a value. Now write down that a value in the denominator. So you have to add a value, that is a 2 in the to the theta. So theta is here, no, here is there, the theta here is there. So we have to add theta, only variable theta. So power as it is. So theta plus 2 whole square minus 4 into theta plus 2 plus 5, like this. Minus 4 into theta plus 2 plus 5 into sine z. Now first of all we have to write e power 2z outside, no. So we are written like this, and this a value we have to add here to the theta. Now remaining trigonometry function we have to keep like this. Okay, now simplify this. So what we'll get here, this theta square plus 4, so 4 theta gets cancelled. This is the, so finally what we'll get, 4 minus 8, that is a minus 4 plus 5 theta square plus 1 into sine z. Okay, now if we have the functional, any functional value like this, so we have to use this formula. Clearly I have given, since we have to use this formula, that is 1 by, this is in the form of 1 by d square plus a square, where a is 1 here, d square plus a square sine ax, here a is 1, right? So what is the formula? We have to apply x by 2 into integral of sine ax dx, x by 2 into integral of sine ax dx. Whereas if it is given this functional value is cos ax, so here we will get integral of cos ax dx. So what we'll get here, e power 2z as it is. So in place of this, so in place of this, what we have to do, so 1 by theta square plus 1 sine z, no, this is the formula. So I will show in the board, and use the pen also. Right. So what is the given here, e power 2z, this is we have to keep as it is. Now what is the functional value? We have given integral of 1 by theta square plus 1, 1 by theta square plus 1 into sine z, okay. Now here b is 1, right? So if we have like this, we have to use a formula 1 by d square plus a square into sine bz, if we have like this, x by 2, that is z by 2 into integral of sine bz, right? So that is z by 2 into sine bz, means here only integral of sine z. What is the formula for integral of sine z? Minus cos z, so what will take, minus z into cos z by 2, into, this is the value is there, no, this is as it is, e power 2z, this is the value of yp, right? So go to the slide, 8th slide we are in, right? So what we got it here, using this formula, so e power 2z minus z by 2 into cos z. Okay, so this is a way to find out the yp, right, using this formula. So using yp and yc, we can put it in the general solution. Therefore general solution is y is equal to yc plus yp. So this is a general solution of the given differential equation. Coming to the next problem, this is a solve x square d square y by dx square minus 3x into dy by dx plus 4y is equal to 2x square. The given equation, right, to put it in the operator form. So x square d square minus 3x into d, capital D, plus 4y is equal to, we can take y common, x square d square minus 3x into d plus 4 into y is equal to 2x square, right? No, take same. These are the steps will be the same. X equal to e power z and z is equal to log x. Now each xd we can be taken as theta, and x square d square is theta square minus theta. Now put these two values in our equation. So what finally we will get, f of theta is equal to theta square minus 4 theta plus 4. Right? Now from this you can write down the auxiliary equation, that is f of m is equal to 0. So this is auxiliary equation. Write down the factors. So we will get the m values are 2 comma 2. Because m minus 2 is a perfect square root. This one m square is equal to what will get m minus 2 is equal to m minus 2 whole square is equal to 0. From that we will get m is equal to repeated roots 2 comma 2. Right? So using the repeated roots 2 comma 2, but this is not in the form of the complex number. We can write any real number will be the complex number. You can write this one as 2 plus 0 I, 2 plus or minus 0 I, that is a is equal to 2 and b is equal to 0. Right? A is equal to 2, b is equal to that. Same formula we can apply here. Yc is equal to e power az plus c1 into cos c1 into cos bz plus c2 into sin bz. Right? So here cos bz, z value here, the b is 0, no? So cos 0 is 1. So c1 is there. No, c2 into sin bz. So sin 0 is c2 plus c2z. So we can take c2z. So but whereas a complex number, it is not the complex number. So it is a real number that can be written as like this, e power 2z plus into c1 plus c2z. Right? So from this, what we'll get here, after that, after construction of the yc, then go to the yp. Yp can be written as 1 by f of d into this is a q. What we got q from the previous slide. This is a q, no, 2 into e power 2z. Right? So here 1 by f of d into 2 into e power 2z. What is f of d? Theta square minus 4 theta plus 4 can be written as theta minus 2 whole square. Now if we substitute theta value here, b value in the theta, we will get the denominator becomes a 0. Denominator becomes a 0. Right? So if we get a denominator becomes 0, we'll get the 0. Then we have to use this formula. Right? Always don't substitute b value in this, in the auxiliary equation, in this denominator part. If we get 0, if we will not get 0, so we can continue. Otherwise, you have to use suitable formulas. So here we have to apply this formula. This is in the form of 1 by d minus a whole to the power of r into e power az. Right? So formula is z to the power of r by r factorial into e power az. So r is nothing but the power. This is a degree. R is the power of the this value. So here this is r. R is 2 here. That's why z to the power of 2. So 2 as it is into 2 into z square by r factorial means 2 factorial into a power z, a power 2z. That is z square, 2 gets cancelled, z square into e power 2z. Okay. So therefore general solution is y is equal to yc plus yp. So substitute yc value and yp value, then we'll get the general solution of the given differential equation. Right? So clearly, so if it's different patterns are there in each problem, the fd value, this is a value will be differ. So in the first one directly we substituted one value because there in the denominator is not equal to 0. Whereas in the second problem, it is given in the form of the product of two functions, e power az into sin bz. So for that, we have applied a different formula. Whereas here, the denominator, if we substitute, the value becomes 0. So then for this particularly, we applied this formula, right? So after that, after getting yc and yp, then we have to substitute in general solution. We will get the general solution. Coming to the next problem, solve x square d square minus xd plus 1 into y is equal to 2 log x. This is a q. No, whereas directly it is in the differential operator form, formula, operator form. So directly we can take x is equal to, we can convert Cauchy Euler equation form. So finally we will get f of theta is equal to theta square minus 2 theta plus 1. Right? From that we can find out the auxiliary equation, f of m is equal to 0, find out the factors. We will get again, this is a repeated factors. This is a repeated factor, that is m is equal to 1 comma 1. Right? Now therefore from this complementary function, what we'll get, yc is equal to e power az plus into c1 into cos bz plus c2 into sin bz. Right? So from that, what we'll get C1, simply it is a C1 plus C2Z, right? Now, after that, a particular integral, that is Yp can be written as 1 by f of d into 2Z, right? So that is because Q value is 2Z. Now, f of d is nothing but theta square minus 2 theta plus 1 into 2Z. Suppose if it is given like this, 1 by theta square minus 2 theta plus 1 into 2Z, right? Now, if we substitute theta, that is a 2 here, so what we'll get here, if we substitute directly, 2, 4 minus 4, that is, we will get 4 minus 4 is 0. 2 square minus 2 into 2, 4. But it is not in the exponential form, no? It is not in the exponential form. If it is not in the exponential form, if it is in the exponential form, we can substitute coefficient of a z value in this denominator. Otherwise, we should not substitute coefficient of, because there is no exponential form, no? So we cannot substitute b value. So we don't know the value, that one here. So that's why we cannot apply that formula. So here another method, we have to apply another formula here. So here I will show in the board. What is a 1 by theta square minus 2 theta plus 1 into 2z, no? So here, what is the screen? Pen also I required, right? So 1 by, so what is given here, functional value 1 by theta square minus 2 theta plus 1 into 2z into 2z is given. So it is not in the exponential form. That's why we have to use another formula, not the exponential form what we applied, that a value we substituted in this, right? So it is not in the exponential form. We have to use this formula is, so this can be written as theta square minus 2 theta plus 1 whole inverse into 2z, right? Then after that, use this is in the form of binomial expansion. 1 plus x whole inverse formula you can apply here. What is a 1 plus x whole inverse formula? 1 minus x plus x square minus x cube plus x to the power of 4 minus and so on, right? So use this formula here. Now write down, rearrange these terms in the form of, first to take it as a 1, after that theta square plus minus 2 theta. So this is in the form of whole inverse into 2z. So this is the one, let it be, this is x. So this is in the form of 1 plus x whole inverse into 2z, right? So use this formula here. So what we'll get, 1 minus x. First is 1 minus x. So x is theta square minus 2 theta. Okay. Then after that plus, what is the next value? X square. So x square means theta square minus 2 theta whole square minus and so on. This is the formula for this expansion of whole inverse into 2z. Okay. Now expand with the functional value. What will get to 2z? 1 into 2z to 2z minus of theta, minus into theta square is minus theta square into 2z, minus into minus 2 theta into 2z. If we take this one, if we expand this one, what will get? Theta to the power of 4. If we apply the theta to the, theta is nothing but derivative, no? If we apply derivative to this, automatically it becomes 0. That's why here itself we are getting the 0. That's why we are not taking these values. From this onwards, we will get 0 values, right? So just we have to expand only these terms. So first term is 2z minus 2 into theta square of z. Theta square of, that is derivative of z, plus 2 into 2, 4 theta of z. Okay. So what is the value here? 2z minus theta square of z is 0. Derivative of z. That is, the first term is the theta, derivative of z is 1. Now again, if it's second derivative of z means constant term derivative is 0, right? Now what about the derivative of z is, that value is 1. Finally, what is the value? Particular integral yp becomes a 2z minus plus 4. This is the value of particular integral. Okay. So for each problem, for every particular integral, so many ways are there. So different formulas are there. right? According to that, you have to apply the, you have to simplify the particular integral, you have to apply the formula, then find out the value of particular integral. After getting the particular integral, that is a yc and yp, both the values, then find out the general solution of the given differential equation. So that is y is equal to yc plus yp. Now substitute both the values in this, we'll get the general solution of the differential equation. Coming to the last problem for this session, solve x square d square plus xt minus 4 into y is equal to x square. Directly it is given in the form of differential operator formula. So no need to convert again. So let it be, this is equation 1. Now apply the Cauchy Euler equation formulas, the formulae, then we'll get finally f of theta is equal to theta square minus 4. Now after getting the theta square minus 4, then write down the auxiliary equation f of m is equal to 0. So from that m square minus 4 is equal to 0. From that, what are the roots we will get? So m is equal to minus 2 comma plus 2. So if it is given minus 2 comma plus 2, now substitute these two values in the complementary function, then yc becomes c1 into e power 2z plus c2 into e power minus 2z. So directly we can take this one as a c1 into e power 2z plus c2 into e power minus 2z. From that formula only, so remaining because only real part is there, imaginary part is 0, no. So from that we got yc is with the both the factors. Both the factors we got yc is this one. In the same, coming to the particular integral, 1 by yp is equal to 1 by f of d into e power 2z. So q value is e power 2z here. So see, I will show the q value here. What is the q value? See here, this is a q value, so e power 2z. So same q value are substituted here for finding the yp, right? Now here f of d is theta square minus 4. So theta square minus 4 can be written as theta minus 2 into theta plus 2 e power 2z. Okay, now for this we have to apply the another formula, right? So different patterns are there. In the first problem, directly we substituted a b value because it is in the exponential function, only single value of the exponential function. And also we have to observe in the denominator should not be equal to 0, right? Then only if it is not equal to 0, then we can substitute the b value in the denominator, right? So whereas the second one, it is in the second problem, it is given in the combination of the e power two functional values, that is e power az and sin bz, right? Now coming to the third problem, if we substitute the b value in the denominator, we are getting 0. So for that we have applied the different formula. Now here also, if we substitute a b value in this, then it becomes a 0, no? So for that we have to apply the different formula. So I will show that formula here. So remember 1 by theta minus 2 into theta plus 2 into e power 2z, right? So I will take again board, I will explain. Otherwise, I will explain here itself. 1 by d plus a. So it is in the form of like this: 1 by d plus a into d minus a e power az. So first of all, if we substitute this b a value in this value becomes 0, no? That's why we separate this value first. 1 by d minus a into remaining values we keep like this: 1 by d plus a into e power az. Right? So now if we substitute a value in this, what we'll get? 1 by 2a into e power az. Now apply the what we applied in the previous problem, no? So according to that format got it here: 1 by d minus a into e power az. So same formula you apply: z to the power of r by r factorial into e power az. Use that formula, we will get the yp value, right? Is it clear? So you, after getting the yp and yc, you can substitute in the general solution. So finally we will get the general solution of the given equation, differential equation, as y is equal to yc plus yp. So this is a general solution, right? So with this, we are going to close this session. In this session, we have discussed a Cauchy Euler equation and its application part 1, right? So these are the Cauchy general equation. In that, we have written the operator form. So from that operator form, one by one, we are writing one by one. X is equal to e power z and xt is equal to theta, x square d square is equal to theta into theta minus 1, x cube d cube is equal to, this is a value, and so on. So like that we have to write. Generally we will have the second degree equation. So up to we are going to use x square d square value. Okay, with this I'm going to close this session. So we will meet in the another session. Thank you.